This video, we're going to look at some of the practice questions related to scientific notation. So let's take a look at this first question here. It gives us a number that is a decimal, is equivalent to which of the following expressions. So we basically want to take this number and put it in scientific notation, and we can tell that from our answer choices here. They're all in scientific notation. So the first thing I'm going to notice when I'm looking at this, because this number is a decimal, I know something about my exponent. It's a small number. A decimal is a small number less than 1. So my exponent is going to be negative. So when I look at that, I can already eliminate choices D and E because both of those have positive exponents. Now, what I'm left with in A through C, they all have this 3.42. So that is the standard way that we write something when we're going to move the decimal to the first two non-zero integers when you're reading left to right. So that's between the 3 and the 4. So we're going to take the decimal point 1 and we're going to see how many positions we will move that. Let's see how many positions we'll move this decimal point to the right. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we moved that 11 positions to the right. So that gives us answer choice B, 3.42 times 10 to the negative 11. Now let's take a look at number 2. The number 724, really big number with 3 sets of 3, so with 9 zeros, is equivalent to which of the following expressions? So again, when we look at our answer choices, they are in scientific notation. This is a very large number with 9 zeros. So our exponent on the 10, the power of 10, is going to be positive. So we can eliminate answer choices F, G, and H. We have an understood decimal point at the end of the number after the last zero. So we have to see how many positions we're going to move that. We're going to move the decimal point to the left, and we'll go 3, 6, 9, 10, 11. We're going to go between the 7 and the 2, the first non-zero digits reading from left to right. So we moved that 11 positions, so that means we're going to have a positive exponent of 11, and that corresponds to answer choice J, 7.24 times 10 to the 11th power. Now let's look at number 3. Evaluate 2 times 10 to the second plus 3 times 10 to the first plus 4 times 10 to the 0 power. And then we have our answer choices here that are not in scientific notation. So there's several different ways we could approach this problem. If you are comfortable with putting scientific notation in your calculator, that is fine. But one thing we have to keep in mind is another way, if we do this by hand, the way to add multiple units in that are in scientific notation is we have to have the same power on, we have to have the same exponent on the 10's power. So we need to convert all these. These are in low enough values that we could just convert them to their regular number value, and then we could add those up. So first of all, let's look at 2 times 10 to the second power. We have a 2 with an understood decimal at the end. We're really going to add 2 zeros on the end. We moved from right after the 2, we're going to add 2 zeros to the end. So that is 2 times 10 to the second power plus 3 times 10 to the first. This means we take the 3 and we're going to add 1 0. It's really just 3 times 10, so that's really just 30. Don't let it get more complicated since we have the understood 1 exponent there. Plus 4 times 10 to the 0 power. Here's a good review. Anything to the 0 power is 1, so that's really just saying 4 times 1, so we're going to add 4 to that. And so that gives us, we can just add that up, 234, and that is answer choice B. Okay, let's take a look at number 4. If 22,000 pots with 15 seeds each are used in a nursery, how many total seeds in scientific notation? So the question tells us, and we can see from our solutions, that they're looking for an answer in scientific notation, and it's going to be 3.3 something because that is what is common in all the answers. It's just going to be what is the exponent on the tens power. We're taking 22,000 pots with 15 seeds in each, and we want to know that total number of seeds. So that's going to be a multiplication problem. We're going to take 22,000 and multiply that by 15. That's a really large number. So we're not going to have a decimal. It's not going to be anything with a negative exponent, so we can eliminate F and G already. If you can either multiply this out by hand or take your calculator, and when you multiply 22,000 by 15, we get 330,000. Now, normally that could be an answer, but they want us to put it in scientific notation. We'll have the understood decimal point at the end of our number, and then we're going to move it 1, 2, 3, 4, 5 positions to the left. That gives us that 10 to the 5th power, which is answer choice K.